Hey guys, welcome to my channel. Today we are going to discuss a very important topic from chemistry, that is symmetry elements and operations. So let's get started. So first of all, what is symmetry operation? A symmetry operation is a movement of a body such that after the movement is carried out, every point of the body is coincident with an equivalent point or perhaps the same point of the body in its original orientation. This means that the position and the orientation of a molecule before and after a movement is done remains indistinguishable. This word should be highlighted, indistinguishable. Next on, we have symmetry elements. Just note that earlier it was symmetry operation and this is symmetry element. Both are interrelated, different but interrelated. A symmetry element is a geometrical entity such as a line, a plane, or a point with respect to which one or more symmetry operations may be carried out. That is, symmetry operations are carried out on symmetry elements. In molecular symmetry, 4 types of symmetry operations and elements needs to be considered. Let's see what are those. So, symmetry elements and their corresponding operations. Plane of symmetry. What is plane of symmetry? Reflection in the plane. Center of symmetry or center of inversion. Inversion of all atoms through the center. Proper axis. One or more rotations about the axis. Improper axis, rotation followed by reflection in a plane perpendicular to the rotation axis. So here I have written rotation followed by reflection. It can also be reflection followed by rotation. Vice versa is applicable. Moving on, plane of symmetry. A mirror plane that divides the object into two equal halves such that one half is the mirror image of the other. So you can understand from this definition that how if a mirror plane divides two objects such that one is the mirror image of the other, then the object or the molecule is said to have a plane of symmetry. It is denoted by sigma. 3 types of planes are there: vertical plane, horizontal plane, and dihedral plane. So this is, you can see it is a tetrahedral molecule, and typically a regular tetrahedral molecule possesses 6 planes of symmetry. These are the planes of symmetry given. So first one we have A, B1, B2. So you can see this is the plane that they are talking about. So through this plane, this molecule is equally divided and become mirror images. Similarly, for the other given criteria also, you can see for the other given points, when you draw them, you can see that it becomes mirror image. Center of symmetry or the inversion center. If a molecule can be brought into an equivalent configuration by changing the coordinates x, y, z of every atom where the origin of coordinates lie at a point within this molecule into minus x, minus y, minus z, then a point at which the origin lies is said to be the center of symmetry or center of inversion. It was a bit of complicated definition, so in simple words, it is a point through which every point in the object is inverted, mapping onto an equivalent on the opposite side at the same distance from the center. It is denoted by I. Like say if there is a point, then both the opposite direction they have to encounter the same environment, that is the center of symmetry. Next on, we have proper axis of symmetry. A line about which object can be rotated by 360 by n and still appear the same. The value of n refers to the order of the axis. For example, C3 means 120-degree rotation around the axis leaves the object unchanged. So how? So here we have 360. If it is divided by 120, then we get 3. So that means the axis is C3 axis. Here you can see there is a C3 axis, and when you rotate 120 degree through this C3 axis, all these points remains equivalent. Also, there is C2 axis through these points. Next on, we have improper axis of symmetry. The axis about which first a proper rotation, then a reflection through a plane perpendicular to the rotation axis takes place. It is denoted by Sn. So here you can see, first of all, we have a figure 1. Sigma is for the reflection. When it is reflected, it will get this figure like this, and then when it is rotated about C6 axis, we get this. That initial figure 1 and figure 4 are the same. Similarly, if instead of reflection first and rotation second, we do rotation first and reflection second, we get the same figure. This is the improper axis of symmetry. Now, if an improper axis of symmetry is suppose S5, that means it contains C5 and sigma, or sigma and C5. C5 axis of symmetry can also be written or expanded as this that I have shown in this picture. So that was it for today. Thank you so much for watching. Subscribe if you want to learn more such lessons. I'll be glad to help. If there is any mistake, kindly forgive me, and comment on what next should I make a video on. And the book that was used to make this video is Applications of Group Theory by F.A. Cotton. Thank you.